just wanted to give you an overview about the development process of my electric jet kayak. So it started with the idea of scaling up the mixed flow water jet design that I made previously to see if on a larger scale it would perform a little bit more efficiently. And so I made, obviously printed it out. I made an aluminum shaft for testing first. Later I changed to stainless steel. And just to see if the thing is any good before I order anything expensive, I decided to test it with the smaller brushless motor and just use a gearbox to simulate the lower kV. So that's what I did, and that's what I tested then. And it appeared that the current draw was okay for this kV, so I ordered a bigger brushless motor to have a direct drive without a gearbox and obviously more power and so on. So this is this motor that we see here, 56104, 420 kV, nice. Yeah, and that I kind of mocked up in the design and was planning the coupling, and I made for now I just made a rigid brass coupling on the lathe. It has obviously more vibrations than like a polymer clutch or something, but for now, and yeah, I think it is okay. Doesn't destroy itself, but it's obviously a little bit louder. Alright, so then I got myself a cooling jacket for this type of motor as well and installed it. And before I cut open a kayak to put the jet unit into it, I decided to test it in like a plastic box and to see if the sealing is any good and so on and so forth, and how to mount it. And yeah, so I made also some adapters for the motor on the lathe so that I can use an old ESC and don't have to buy a new one yet. So here we have everything kind of set up. Motor, ESC, old LiPo battery. And yeah, so I tested it and it performed pretty well, but I decided to use an open impeller because the closed impeller is great on paper, but it's horrible when you print it because the surface finish is just not good enough with FDM printing. So yes, I went with an open impeller and I changed the geometry of the housing a little bit so it's more optimized for open impellers. So then I printed that out, I sanded it a little bit so that the impeller fits, and I also designed it with an aluminum screen in mind. So basically just take some small aluminum bars and stick them in the slots for it, and yes, and hopefully this will help to increase the lifetime of the 3D printed impellers so that they don't get hit by rocks and stuff. So then I also made a new nozzle design with more fins and a little bit lower pitch on the stator of the pump. Yeah, and this kind of just decreases the amount of vortex of spin that's still in the fluid when it comes out the nozzle. It kind of makes it a little bit more efficient. It also looks nicer. Yeah, and also I just drilled a hole into the pump section of the pump and the high pressure section, and put a little bit of a tube in there, and this is for the water cooling, and that also turned out to be a viable idea when testing. So yeah, so I decided to take an old kayak and just a polyethylene kayak. It's already was in pretty rough shape, so yeah, anyway. So I made a saw guide out of wood, so I can more or less saw the back of the kayak off straight, and yeah. And then I realized that when placing the jet inside, that there is a little bit of a gap between the jet unit and the boat. So I thought, well, it's just plastic, so I used a heat gun that I bought a while ago to fix my phone, and heated up the bottom of the boat and flattened it between two, basically sandwiched it between two pieces of wood, and that turned to work better than expected, even though the plastic is like 6 millimeter thick. Yeah, so I then cut out the inlet with the jigsaw, and yeah, it's not the nicest cut, but it's fine. It's kind of hard to saw on like a curved surface and so on and so forth. So yeah, I screwed on the jet unit with some probably really oversized bolts, but that way I don't need to worry about it ever coming loose. And yeah, then I made a rear plate. I kind of thought about plastic and aluminum, but aluminum was too heavy, and plastic, yeah, I would have needed to order that first, so I went with plywood and coated it with resin to make it waterproof, and put it in, screwed it in, and yeah, and then I installed the drivetrain. Basically the same procedure that I did with the box. Motor in place, ESC, and so on. And also fitted the steering nozzle, installed the water cooling, and the steering servo I just placed on like the rear bearing housing. Yeah, and for now it's just a rope pull mechanism, but maybe in the future I will put a more rigid steering link on there. Here's a bilge pump. It's just an automatic pump that turns on when the water gets too high. Yes, and it can make obviously a little bit of a plumbing mess with all the silicone tubes going everywhere, but that's okay for now. And then I just put some pool noodles in there, just in case I get a bad leak or something in the boat, so to prevent it from totally sinking. But it didn't sink, so yeah, anyway. And yeah, that's pretty much it for the development so far. And while testing, I realized that there is not enough dynamic lift, so the boat doesn't really go on plane. And yeah, so this is what I'll try to fix next, with maybe a right plate, and if that's not enough, maybe some adjustable trim tabs or something. Or maybe just angle the jet down a little bit, because I think the center of gravity is just too far back, with like the drivetrain, battery, and me all sitting in the back, and yeah, that's kind of not so great. But yeah, putting the battery in the front would also be kind of bad, because then I would have less space for my legs, and also I would have to put like a giant cable through the boat, and that's also not very efficient. So yeah, I think I'm just gonna leave it with that, and yeah, trim tabs, right plate, angle the jet down, something like that. So yeah, and also I'm probably going to be ordering a bigger battery next to test it also with some high voltage, because it turned out that the inlet is doing the pump inlet is doing something good for the pump, so it draws a lot less current than in a static, pumping test. I don't know, I think I calculate something like 300 amps static for like a 6-cell battery, but it only when driving on average draws 140 amps, so there is actually room for more. Maybe with like a 300-400 amp ESC, I can even go to like 12S or something.